Hello and welcome to the part 5 on functional interface. In this video, we will see how a functional interface is linked to a lambda and why is a lambda needed for a functional interface. Before we get there, let's see how do we implement a functional interface, or how do we give definition to a functional interface in a classical manner or before Java 8. So as you can see, I have an interface called the calculator, and I have a public abstract method called add, which takes in two int arguments and gives a return int type. So this is just the contract which says what has to be done, and it doesn't say anything on the how part. To implement the how part, we have a class called the calculator IMPL, which implements the calculator interface, and it is forced to override the add method. And here, if you see, we have to give the definition for the add method. So the interface is the what has to be done, it is the contract, and the implementer class is the how part of it, how it has to be implemented. And to call it, we create an instance of the implementer, class, and on that instance we call the add method. When we call the add method, this logic gets executed. So it is 20 plus 30, which is 50. There is nothing new in this. This is business as usual. Before we go to see how using a lambda we can implement this functional interface, I want to give you a bonus tip. I want to show you how we can do or implement a functional interface not just with the classical method, not just with the lambda, but also by using an anonymous inner class. Anonymous inner classes are made up of two words, as you can see, or rather three words: anonymous, inner, and classes. Let's break it down. Anonymous in English, as you know, is something that does not have a name. Class is a class. Inner class is a class within a class. A class within a class is called an inner class. So a class within a class which does not have a name is called an anonymous inner class. Now let's see how it is implemented. We have the same functional interface. It is called a functional interface. Why? Because it is an interface which only has one and only one public abstract method. The abstract keyword is automatically added by the compiler. You don't have to explicitly add it. You can, but it is not needed. And if you don't add it in the declaration, the compiler will add it at compile time. So it's a functional interface because there is only one abstract method. And how do we implement this? So does this statement ring any alarm bells for you? So what we are doing is we are applying new. New is generally applied when we creating new instance. We are applying new to an interface. And in Java, can we instantiate a interface? The obvious answer is a no. We can't instantiate a interface. But if you see very closely, we are saying new calculator and we are giving a definition to the add method, definition to the abstract method of the calculator interface, and we are overriding it and giving definition or body to this method. So ideally, if you see, it is a class. How do I say a class? Because it is a class that implements the calculator interface and does not have any name. This is a class which does not have any name and it implements the calculator interface. That is why it is called a anonymous inner class. And on this instance of the anonymous inner class, I will call the add method. So cal.add 20, 30, which again gives me 50. Thank you, friends. Hope you like this video. In the next video, we will see how do we implement a functional interface using a Lambda. Thank you.